That's a good side topic. We should talk about that too, because that's really helpful to understand how that's working. So somebody here remind me in a couple minutes to talk about thinking models and how they work. The sequential thinking breaks the problem down into multiple questions. And then it goes through those questions and answers them one at a time. And if you pair it with a thinking model, then it does additional thinking on top of breaking that down. It works with any. It's extra powerful with a thinking model. One thing to note is using any of these tools may inflate your API token usage if you're doing key-based usage. For example, if I go over here and this is Windsurf, I have Claude Sonnet 4 thinking enabled, and I'm using the bring your own key feature. So I've gone into Windsurf and I've given it my API key to use. If I work on an application for 2 hours, depending on what I'm doing and how many tool calls I use, that might cost me $10 to $20 in API usage, which would be less if I didn't use as many MCP servers. So we're going to talk about the balance there. Okay, Taylor, you put a little comment in there about thinking models and how they work. I think we should cover it real quick and then get into the MCP stuff, because this is super useful to know. Large language models are not actually thinking of anything at all. Even in thinking mode, they're not thinking of anything. What's happening is they are trained, and all of that training is converted into tokens. Every single bit of training is converted into tokens, which are little strings of numbers, basically. Have I shown you all the tokenizer tool? This is kind of cool to see. You can put in any content and see how it breaks it into tokens. So this right there, that purple, that's one token. The space and the is another token. The A and a space is another token. And then this last 5 characters here is a token, right? They look like this. Just token IDs. All of these are what the AI has been trained on. Every piece of content has been broken into tokens. And then those tokens are all what it's been trained on and how its memory has been created and its decision-making process has been created. And what it does is when you ask it a question, when you send it a prompt, it says to itself, now I'm oversimplifying here, but this is basically what's happening. It says to itself, I have seen this string, this set of words. I've seen this string of tokens 300 million times. And the most common response or responses to that string of numbers is this string of numbers. And that's its reply. It's not like being smart or anything. It is just saying predictively, when you say this, this is what's most commonly going to come out. This is what I saw every time I was trained that came after that sequence. And then the thinking models, they do one step in between there. They go through and say, if I were going to plan my answer before I answered, here are the common responses. Here's the common strings that I would consider, because there might be 150 different common strings that came after the words, this is a test, that it's familiar with. These are the things I would consider before I actually answered and gave them my response of the common strings that come after that. In doing that, it gives it an extra chance to zero in on what the highest probability is that the strings it tells you are the right ones. We'll jump over to MCPs again. All right. So file system, we've talked about. Fetch, we've talked about. Memory is a really fun one. So when you're building an application, it's good to train your AI on what you've built and basically give it a memory system to be able to recall information, because it has no memory. If you open a new context window, it knows nothing. Now, some AI tools, for example, Windsurf, has memories built in. So you can tell it create a memory and it'll store it here. And what happens with this memory is it's got a bunch of information that I've told it to remember about this application. every time I send a prompt, this memory goes with it. So again, that can inflate your token usage if you're paying on a token basis, but absolutely worth it if you want accurate coding capability. But not all of these tools have memories. And even that memory has some weaknesses of just being a string of data. So what the memory tool does is it creates a knowledge graph. I don't know if I have it up here. Yeah, I have it here. It basically creates a knowledge graph of whatever you tell it to remember, like this. Creates a little knowledge graph of whatever you tell it to remember. And then those are all related. You can then tell the AI tool to go look at the memory and say, hey, find me the information about this feature. So your user pattern changes a little bit. You go and say, I'm going to build a feature. Before we build the feature, look at the memories and see if we have anything that's related to this feature. And it looks at the memory knowledge graph and says, yes, no, maybe. And that loads that into the context. And then you do your feature build. And then you say, okay, now let's add to our memory everything we just did and relate it to everything it's related to in the knowledge graph. It will basically build up a knowledge base that you can always reference semantically about your application. Creates a persistent memory there. Question from Tony, does that mean the more rules you have in an IDE, the more tokens are used on each call? It is exactly what that means. Yes. It gets sent with every prompt, and just like any context window, you send that with the first prompt, it replies back or does actions. All those actions are stored. And when you reply, the initial stuff, its actions and its responses, now your new reply all go back up. So your context window fills up quicker this way. So if you're using tools like this, it becomes even more important to keep it to one topic, one context window. But that is exactly what it means. That there's a lot of compression that goes on in context windows, and some apps do it behind the scenes. Other apps show you that it's happening. So if you're using Kilo Code, for example, or I think Klein does it as well, you see the compression happen. So they show you, hey, your context window is almost at 200 tokens, and it'll compress it down and just basically summarize the context window into a smaller bit. That's what goes back up. But as soon as that happens, you've now lost 80% of your total context. Now your context window has become somewhat useless. It keeps the conversation going, but it's not great for development. All right. We are going to go over here and look at this one. This is the file system one. So these are the features that it can do. It can read, write files, create lists, delete directories, move files, directories, search files, and get file metadata. Now, every one of the AI coding tools has a read, write files tool call available to it already. So I do find that this sometimes gets in the way. It will try to use the MCP to write files rather than its own tool call. And depending on what's going on with your AI tool, it'll work and sometimes it won't. So it really depends on the situation as to whether this feature is actually useful, if it's just in your way. And I'll show you how I deal with that. But the rest of these are super, super handy to have. And then let's see here. If you are doing any time setup on a server, this is actually super handy. Just turn it on and have it help you with the time configuration. For example, if you're publishing an application that might be showing user-facing information in a particular time zone or in a particular format, the AI can sometimes get confused about what the time zones and how they relate. So if you put this in, it gives it accurate information for setting that up. But I wouldn't leave it on all the time. I'd turn it off if you're not using it. Puppeteer is another one that is really handy. It's similar to Fetch here, but it uses a headless Chrome browser and can sometimes see websites a little better. We'll pull up its tool set. So it can go to any URL and it can take a screenshot and bring that back in to your application for context. So this basically gives your AI eyes. It can see what's on the screen. Again, only if headless browsers aren't blocked by the website you're trying to open. This works really well for opening the apps that you're developing locally and saying, hey, run that and take a look at this thing on the screen. And it'll use Puppeteer to take a screenshot and bring that back in and load it right into the context. So it's basically lets it see the sites you're working on, but it can only see what's above the fold. It can't really scroll around well. And I've found that it doesn't, the fill tool and hover elements, they're very unreliable to work. But as far as getting it to see the screen and load that in, it's actually really useful for that. And then there was one other here that I wanted to mention that is pretty cool. Let's see if I can find it. I think I scrolled past it. Ah, yes, 21st Dev Magic. I'm mentioning this one for two reasons. One, this is connected to 21st Dev's Magic AI component builder. So it has a bunch of AI components, or excuse me, design components that AI can use, and that they're formatted with prompts to be brought into your application. So if you try to design something, you're like, I want a button like this, then the MCP can go out and find it on 21st Dev and pull in that component so you don't have to rebuild the whole thing. They just style it to fit your application. I also bring this one up because some MCP servers, a lot of the ones I've talked about are free. They operate and you can just use them. This one is not. You pay for access to what it's pulling down, and then you use an API key in the MCP server so that it can access that information.
Courtney, on 21st Dev, it's very easy to just copy the code and paste it in. So why would you need the MCP for that?
That's a great question. The reason for the MCP is so that you don't have to go search for the code yourself. It uses the knowledge of your application and goes and finds it by itself. Is that a good thing or a bad thing? I leave that to you to decide.
Seems unnecessary, really. It just seems a waste of tokens.
It does. Let's say that when this came out, I used it and I was not impressed. A few months later, I used it and it was successful at finding some elements very quickly, and I didn't have to go look for them. It was like time versus searching. But yes, you can just go and access all of their templates and just copy and paste them if you want. Thanks for watching. If you want to see more videos like this, please like and follow. And if you need help building or finishing your app, click the link in my bio to book a one-on-one Zoom call to take a look at your project.